Mathematics teaching learning can be enhanced using different strategies. Origami is an art of paper folding. Paper folding can be used to make and explore various geometrical figures. Dear students, today we are going to make and explore various geometrical figures using paper folding. For doing this activity, we need the following materials. We need few sheets of origami, a ruler and some markers. Let us take an origami sheet. When we fold this origami sheet, we get a crease. When we unfold, we see this crease, and this crease can be taken as a line in mathematics. On this line, we can mark 2 points A and B. When we join these 2 points using a ruler, we get a line segment AB. This is a line segment AB. Now fold AB in such a way that point B falls on point A exactly. Mark a crease. Unfold this and observe that we get a new point on the line segment AB. Let us mark this point as M. What can you say about this point M? This point M is dividing AB into 2 equal parts. So, M is the midpoint of line segment AB. Now, let us further see when we make this crease passing through M and extend it. Unfold it and you can see a line which is perpendicular to AB and divide AB into 2 equal parts. What do we call such a line? We call this line as perpendicular bisector of line segment AB. So, till now we have seen that by folding we have taken a line segment, the midpoint of a line segment and the perpendicular bisector of the line segment. Now, let us see how to make an isosceles triangle using origami sheet. Take a sheet of paper, fold it, you get a crease, and imagine that this crease is line segment AB. We have marked again 2 points on this line, and AB is the line segment which is considered as base of the isosceles triangle. Now, we will be using the same strategy, that is, first of all we will get the perpendicular bisector of AB. So, we have got another crease which is perpendicular to line segment AB, and this crease is dividing AB into 2 equal parts. Now, you know the geometrical result that any point on the perpendicular bisector of a line segment is equidistant from the end points. So, let us see here, we have a line segment AB. Let us draw this line segment AB. This is the base of isosceles triangle. This crease, the second crease, is perpendicular bisector of line segment AB. Now, if we take any point on this perpendicular bisector, that point will be equidistant from the end points, that is point A and point B. So, let us mark a point P on the perpendicular bisector. P is a point on the perpendicular bisector. Now we will make crease joining PA and another crease joining PB. Now you tell me, what is an isosceles triangle? A triangle having two sides equal is called an isosceles triangle. As you can see that PA is equal to PB. Because PA is equal to PB, it is an isosceles triangle. Now we will draw this triangle PAB. So dear students, we have learned how to make an isosceles triangle using paper folding. We have isosceles triangle PAB in which PA is equal to PB. Let us now take another sheet of paper and make an equilateral triangle. What is an equilateral triangle? An equilateral triangle has all the sides equal. So, we will make first crease. This crease is giving me one side. I have marked the points A and B, and AB is one side of equilateral triangle. We will make the perpendicular bisector by folding along AB in such a way that point B falls on point A exactly. Now, in an equilateral triangle, all the sides are equal, and we know the property of perpendicular bisector of a line segment, that any point on the perpendicular bisector is equidistant from the end points of the line segment. So, we will make a point on the perpendicular bisector in such a way that AB is equal to PA and PB if P is a point on the perpendicular bisector. See how we are going to do this. We will move point B on the perpendicular bisector and mark a point on the perpendicular bisector such that PA is equal to AB. Now you know that any point on the perpendicular bisector is equidistant from the end points. So, PA will be equal to PB and PA is equal to AB. So, all the three sides will be equal. So, let us make crease joining P and A, another crease joining P and B. You can see that we have a triangle PAB such that PA is equal to AB is equal to PB. Now, on the crease you can draw this triangle. In triangle PAB, all the sides are equal, so it is an equilateral triangle. Now, let us see how to make a parallelogram using paper folding. You can take any sheet of paper. Earlier we were taking origami sheets. If you have an A4 size sheet, you can use that also. And if you have any sheet like this, you can use this also. So, let us make a parallelogram on an A4 size sheet paper. First of all, we will make first crease, unfold it and number this crease as 1, and we will draw a line on crease 1. Now we will make another crease which will be perpendicular to crease 1. Now you can see that how I have folded this. This is first fold and this is second fold, and the second fold is making a crease perpendicular to the previous crease. Unfold it and number this crease as number 2 and draw the line. This is crease number 2. Now we will make the third crease perpendicular to crease number 2. You see, we have repeated the same process. This is crease number 2 and this is crease number 3. See, the angle between them is 90 degree. So, these two creases are perpendicular. Unfold it and number this as crease number 3. Draw a line on crease number 3. Now observe this carefully. If I say crease 1 is parallel to crease 3, am I right? Let us see. Crease 1 is perpendicular to crease 2. This means this angle which I have marked is 90 degrees. Now crease 2 and 3 are perpendicular to each other. So this angle is also 90 degrees. Now observe this carefully. Line 1 and line 3 and line 2 is acting as a transversal. 90 degree plus 90 degree is 180 degree, which is the sum of two interior angles on the same side of the transversal. So line 1 will be parallel to line 3. Another way of observing this, line 1 is perpendicular to line 2, line 3 is perpendicular to line 2. You know that when two lines are perpendicular to the same line, they are parallel to each other. So line 1 is parallel to line 3. Now we have to make a parallelogram. So we will be making another pair of parallel lines. For doing so, we will make a crease passing through lines 1 and 3. Name this crease as number 4 and draw a line on this crease. Now we will be using the same process because we have to get a line parallel to crease 4. So we will make another crease perpendicular to crease number 4. See, this is how we are doing this, and when you are making such folds, make sure that these folds coincides. Unfold it. On the new crease, you give a name. I have numbered it as number 5 and draw this. Draw a line on crease number 5. Now we have to make a crease which is perpendicular to crease number 5. So you can see that I am taking crease 5 as the base now. So I have to make a crease perpendicular to crease number 5. Again observe this angle, it is 90 degrees. Unfold it and number the new crease as crease number 6 and draw another line. Now observe this carefully. Crease number 1 is parallel to 3 and 4 is parallel to 6. Now can you see and observe a parallelogram here? I am marking the points A, B, C and D and drawing a parallelogram using a different color. Here ABCD is a parallelogram in which AB is parallel to CD and AD is parallel to BC. This is how we get a parallelogram using paper folding. Now we will be making another geometrical figure using paper folding. Let us take a sheet of paper and I am asked to make a rhombus using this. Fold it into two halves. Now you can easily tell me that this is perpendicular bisector of the two opposite sides. Again fold it and make another crease. Now you can see that this parallelogram, this is a rectangular sheet of paper. This is divided into two parts and then four equal parts by folding in this manner. Unfold it. Now observe the two crease and mark the points A, B, C and D. Now join AB, make a crease like this, then join BC, you get another crease, this is BC, and join the points C and D by crease CD and join the points A and D and make another crease. Can you see what we have got? We have got a rhombus. Now you can give a reason why this is a rhombus by exploring various geometrical properties of rhombus. Now we will see how to make a kite using a rectangular sheet of paper. First of all, we will fold the paper and make the perpendicular bisector. This is the perpendicular bisector. Now fold the paper and make the second crease by taking any suitable distance from the top like this. Unfold it. Again you can see and mark 4 points A, B, C and D. Now you make a crease joining points AB, make another crease joining points B and C, then make the third crease joining points C and D and make the last crease joining points A and D. Observe this shape. This is a kite. Dear students, you have learned to make and explore geometrical figures using paper folding. You can do the same explorations on different geometrical figures by paper folding. Thank you.